Hi. Hello. Okay, so welcome back again. So now in this video we're going to be calculating position. Okay, so we're going to be calculating position using the position equation that we have for the uniform linear motion. That is this one. Okay, it's the position that is equal to the initial position plus the velocity times the time interval. Okay, so this is the formula that we're going to be using right here. Okay, so now let's gonna check the problem. This is the problem. It's about a motorcyclist. It says the figure shows a motorcyclist traveling east along a straight road. After passing point B, the cyclist continues to travel at an average velocity of 12 meters per second east and arrives at a point C 3 seconds later. What is the position of the point C? So we're gonna have as initial data the 12 meters per second, that is the velocity, 3 seconds, that is the time interval, and the initial position, that is 46 meters east. So I'm going to use the formula and I'm going to substitute the data from the formula. Okay, so in the formula the position is equal to the initial position plus the velocity times time interval. So substituting this, it's equal like this. The initial position, that is 46 meters, plus the velocity, that is 12 meters per second, times the 3 seconds, that is the time interval. Okay, now I'm using the positive values as east. Okay, so 86 meters was east, 12 meters per second was east, so therefore this 82 meters, that is result, is 82 meters east. Okay, so remember that we are calculating a vector quantity, so we have to mention the direction of the vector. Okay, so in this case it was 82 meters east because it's a vector, which is a position. Okay, guys, so that's all for this video. I'm still uploading videos right now. Okay, so coming up next, I think we'll have another position problem, but it's gonna be a little bit different than this one. Okay, so see you guys in the next video.